Wednesday evening, 5:41. It's the 4th of February 2026. Of course, we're looking at Jupiter. The interesting thing about it is this look is, let's get the magnification set right, is a 300x view. But guess what? I'm using a 50 millimeter aperture at this point. I basically removed the aperture stop from the mirror cap on the optical tube assembly. We're only getting 2 inches of aperture. At 300x, we basically turn the scope into something like it's an f12. But we're getting a 300x view, and we are showing both the equatorial belts, northern and southern. Northern is to the right and southern's to the left, and we're getting hints of the belts further north and south, temperate belts, plus the darkening in the polar regions. I've set the focus as tight as I could, and this is very intriguing that we're getting so much resolution using the mere 50 millimeters, because 50 millimeters will only give you about 2.5 arc seconds of resolution, and Jupiter is only about 45 arc seconds in diameter. So we've basically broken it down into 2.5 into 40. We'll call it 1/15 segments, 1/15 of its actual view. Now I'm going to switch it over to the full aperture. Then of course I'm going to have to adjust the exposure time when I do that, because we're going to emit far more light. But look how nicely contrasted the view is. Now effectively, however, we're at 50 millimeters aperture, and since I precisely located the cap so that we didn't get any diffraction spikes from the vanes supporting the secondary mirror, this isn't really a bad view. And how do we manage to get 300x out of it? I don't know. Very intriguing little experiment. Give me a moment. Okay, what I'm going to do now is play with the focus a little bit, because we're seeing the Galileans, all 4 of them. Watch, I'm going to rotate the fine focusing knob we're looking at in a clockwise direction a little bit. Not very much, and then in the counterclockwise direction. All right, now what we want to do with Jupiter is we want to either use the limb or we want to use the Galileans to set the best focus and then lock it down. I'm going to kind of leave it right. It's hard to tell because I'm away from the screen when I do this. How's that look? Now, that's diffused. Of course, atmospherics is playing a role here too. All right, I think I'm going to lock it down right there. Okay, having locked it down, I can now play with the histogram. We're going to drop the exposure down to about 50%. Boy. All right, about 50%, and the gain down. We're not doing very well, so what I'm going to do is change the range. Okay, we've darkened it up considerably now. Now I'm in the microsecond exposure time. Wow, it's still very, very bright. Oh, come away. Something popped up I didn't want to have pop up. Okay, we are not getting a very good view, and notice how much better the view was when I used the aperture stop. And that's because it filtered out a lot of the atmospherics and we used a much longer focal ratio. So yeah, I'm a big person for, if you want your aperture to fit the night sky seeing conditions when you're doing lunar planetary. And that was quite astonishing. Look how out of focus. Let's drop the aperture block stop back on there and watch it change. Of course, it's going to get very dim. So I would basically say that I need more experimentation on this. I can play with the focus a little bit more, but I don't think it's going to improve things. One more minute here. You can watch as I do this. Slight rotation clockwise. A slight rotation counterclockwise. Don't seem to have gotten any improvement at all. So, basically what I've demonstrated is there's probably an optimal aperture for the seeing stability on any given night. It'd be way cool if telescopes had like an iris on them that you could adjust the aperture. I know some people do put screens over their scope so they can take advantage of a little bit of diffraction as well in order to improve their views. But it'd be very intriguing to have an iris that you could adjust the aperture, especially if you had a refractory telescope, to basically stabilize the image under the best conditions based on the atmospheric instability. So there goes our experiment. I may run for another minute later just in case atmospheric stabilize. So with that, I am going to head out and have dinner. Well, it's 6:15. I had a very nice dinner. And the view hasn't improved much in terms of atmospheric stability. I think it's time to go on to the NGC. I believe it's 1500 to 1549 this evening. I'll double check on mine to see what the last one I did. And we shall go ahead and do some deep sky, which will involve a lot longer exposure times than 6,494 microseconds with a gain of 189. And with that, I'm going to say carpe noctem. There's not a very good view tonight, but at least we saw that an aperture stop really helps in improving the view that you will get of planetary studies if the sky is unstable as it is now. Carpe noctem.